Record, share. Boom. Look, I'm back just like that. That was like 5 seconds. Okay, so on the left side of the screen, we're going to do f of g of x. And then on the right side over here, I'm going to do g of f of x. And do you remember from yesterday, what's the result that we're looking for?
X.
Yep. If the answer is x, then we have both answers have to be x. And so on the left side, if we do f of g of x, that means we're going to do f of x, which is blank minus 1 squared. And what are we going to put in the blank? Oh, cubed. I'm sorry. That's supposed to be a cubed. I apologize for that. My paper was tilted at a funny angle there.
The square root of x, or the third root of x plus 1.
And it's the negative, I believe. So we have to put in the g of x, which is the negative cube root of x plus 1. So yesterday I put some parentheses. If you remember this example, I kind of did one like this, and I put some parentheses where x was, or the input was going to go. It kind of gets a little gummy if you do that. So it's up to you. So what do we see that's going to happen here? For sure, the plus 1 and the minus 1 are screaming at us. So get rid of those guys.
The degrees.
Yeah, so like we have a cube root.
The index.
Right. The index and the power are going to kill each other out, right? So what we have now, I'll just clean it up a little bit, is we have the opposite of the cube root of x raised to the power of 3. So we're going to cancel out our roots in this case. So we're going to cancel out the 3's, and we're going to be left with what? Negative x. Which doesn't work. Correct. So we could stop on this one already. We don't even have to do g of f of x, because if f of g doesn't work, then we don't actually care if g of f does. So those are the best ones if you get halfway home. Yep. So they're not inverses. Correct. So we're not there's. I used to give an assignment a long time ago that would be like, verify that these are inverses. And that kind of ruins the fun, because like you already know they are. You're just kind of working to a foregone conclusion. What's different now is we're working to an answer that we don't know. So the answer is no, they're not inverses. Let's try number 2. Okay, so again, you do not have to proceed in that problem, because if one of them doesn't work, the other one is irrelevant. So in question number 2, again, I'm going to move this paper closer. So we're going to do f of g of x first. And if necessary, we'll do g of f of x. So f of x is the opposite of blank plus 2 cubed. And then in that little blank space that I've left, I am going to put in the function g of x, which, and I'll use colors again, is the opposite of the cube root of x minus 2. So again, we see the basic arithmetic. We see that the minus 2 and the plus 2 are going to cancel each other out, and we're left with this. And so this, you can see like these problems are cut from very similar chunks of cloth, huh? But what's going to save the day here? The negative, and yeah, that red negative. This is going to be what changes the situation for us this time. And so like this time, when we take the two things in the yellow circles and we let them do their thing together, the cube and the cube root vanish, leaving us with negative x. But this time, that negative out in front is there to save the day, and the negative of a leftover negative x is a positive x. So that doesn't mean that we can say yes. It just means that, like, so you're saying there's a chance, right? So now we got to go and do the composition the other way. And that's going to be g of f of x. Bless you. So again, the idea with this is the one that you say first is the one that you start writing first. So g of means to take the function named g, and that is going to be negative. And then we do a cube root of blank minus 2. And I made that blank a little longer this time because I know that I'm going to be putting some business in there. Because now where the x used to be, the other function's going to go. So what's going to go in there? Right. So we have the negative of, and I do need these parentheses, the quantity x plus 2 cubed. Still good? Okay. So there's, I mean, this is like someone who doesn't like algebra and distribution and stuff, this would be like a nightmare for them, like waking up in a pool of sweat, kind of thing. So the first thing that has to happen is we have to acknowledge the radical power thing. The order of operations demands that of us.
We have to break out the X plus two.
Yeah, essentially, yeah. By that you mean like we're gonna kill the threes?
Yeah,
Yeah.
when you do that though, does like -2 come out where it has to stay still, right? Because it's not.
Are you talking about this guy?
Yeah, like
He's got nothing to do with what we're talking about right now. He's not part of this conversation.
it's
He's
not inside the.
no, take a look at how the problem's written. You see how how the ceiling on the radical ends at the X?
Yeah.
The -2 is not in there. That would be a deal breaker if it was. But in this case, the cube root and the cube are perfect offsetters. And whenever that happens, then we're just left with what's inside. So we wind up with the negative of, and I'm going to use some creative brackets here, negative x plus 2 minus 2. And I elected to use those funny looking parentheses just because math people, what's the matter?
I just feel like slightly, I don't know what's going on.
Hold on, let me pause this real quick. I hate when I do that.
Well, it's just answer guys.
Yeah, it's like on the screen, so someone could just like pause it, right? Like if Blair was watching this, will Blair watch this?
Yeah.
Oh yeah, so she could pause it and then look at it and figure out what we did. Yeah, okay, good. So then I'm going to scroll on. Yeah. So I wanted you to see in question 3, and then I'm really not going to keep doing these with you. Oh boy, I'm going to do number 5. But I'm going to do 3 first.
Question 3 is Recky.
I'm sorry, did you say it's Recky?
Yeah, it's weird. There's like a fifth root there, and then like a third root there, and you got to transfer it over, and then you end up with like a fifth and a third, and like a.
Yeah, you pretty much, I think, summarized exactly the point I was trying to make earlier, that some of them just really stick out. Let's just get in here and take a quick look. So let's do f of g of x, which again is going to be, we're going to write down the function named f, which is 2 minus blank to the 5th. And this is going to go off the rails pretty quickly.
Can you change that minus to a plus since there's a minus? Like first name. Like your d of x is like the opposite.
No, because the order of operations says that exponent gets priority. Like you putting that negative in early is like flipping the bird to the order of operations. The exponent has to go before that negative can intrude. Okay, you guys are leaving. Okay, bye. This will be only a very short, like 10 minutes left, 8 minutes left in this video. So watch it if you can. Hey, good luck. Bump set spike. Okay. Yeah. Bump set spike. Good. Okay. So here's my 2 minus x to the 5th. And then in place of x, we're going to put, I'll change colors to negative x minus 2 to the 3rd. I don't even know what to make of this, quite frankly, but this is hilariously bad. So here, let's press on with this dumpster fire. So this is going to be 2 minus the negative of x minus 2 to the 15th power.
Yeah.
And I feel like at this point in time, we're within our rights to probably throw in the towel. So you can see what happens when, like powers need roots. And quite frankly, like third powers need third roots. We've got the ultimate catastrophe here. We've got a third power and a 5th power. There's no way that those are going to play off each other to make that sweet, like leveling off at X. So we could stop right at this point and say, yeah, no go.
I was about to ask, do we have to like try to do this? Like, just say,
No,
doesn't work?
no, you're allowed to be intelligent about this, and you got to go at least far enough. Like if this was a test, I wouldn't want you just to put no. Like, bless you. I'd like to see just enough work where you could stop with a clear conscience and say, there's my proof. Like this isn't going well, right? Can we all agree? Like there's no way this is coming back to X.
Yeah.
Okay, so I'm going to skip past number 4, unless you want to do it. It's up to you. So let's head to 5. And the reason I want to talk about 5 before I stop the recording is because 5 has the F word. in it, fractions, right? And then this is an issue. So we're going to do f of g. I'm a creature of habit. When I compose as a student and as a teacher, I always do f of g before I do g of f. I don't know why. So it doesn't matter, by the way, to you what order you do them in. So f of x is 4 over x minus 1. But here's where it gets interesting. And actually, it's not that interesting. Maybe you'll find it to be uninteresting, or maybe you'll be like, actually, that was kind of interesting. We were about to find out. In place of that little space that I very purposely left there, I'm going to put g of x, and g of x is, this is way less exciting than I thought it was going to be, 4 over x plus 1. Yeah, I really thought there was more meat on this bone. What happens here?
The ones go away.
The ones go away, and we're left with this math problem right here, 4 over x. And what does that mean to do?
No X.
Copy dot.
Oh, you can't do that.
Thank you. Copy dot flop, right? There's nothing dying here. This is just a division problem. So what this really is copy 4 over 1 dot flop x over 4. And now we'll see that the 4's cancel. And hey, guess what we got? Perfect. I mean, honestly, that's bad news because it means we have more work to do. Hey, it's nice when you get like 12 and then you can just stop. But we got to keep going now. Any confusion on that? All right, let's go the other
Where'd the
direction.
4 come from?
Because when I do like, if I had to do like 3 divided by like 2/5, I would make it 3 over 1 times 5 over 2. I think it's good to always have things over 1 so that fractions can play with fractions. So I just did that on because I wanted to. Better? All right, let's go the other way. Let us do g of f of x. And that is going to be the function named g, which is 4 over open space plus 1. And what's going in that open space?
4 divided by x minus 1.
Correct. Again, I guess these just I'm thinking at some point I got to come up with some better ones than this. These don't have quite the meat on the bone that I was hoping. I'm going to send these wings back to the store. Again, I think what you see here is a very simple example in this yellow box of copy dot flop. There's really no need for us to do common denominators or any of the stuff I was hoping we'd get to do. So I'm going to switch that yellow box now to say 4 over 1, right? Times what?
4 over x minus 1.
Yeah, times x minus 1 over 4. Remember, copy dot, it's not copy dot keep the same, it's copy dot flop. And then something rad happens, huh? The 4's are going to go bye-bye. Kapoof, kapoof. And then we're left with x minus 1 plus 1, which equals
X.
So we can say, yes, these two functions are inverses of each other. You guys think you can handle about 15 more of those? Let me know if you need some help. I'll keep the recording alive, but I'll pause it. And then if you got a question, I'll unpause it and we'll do it together. So yeah, so number 7, I'm going to do f of g first. And my spidey sense, my common sense tells me that there's no way that two functions can be inverses if they're the same. But I'm wondering, again, since they're rational functions, and we haven't done our unit on rational functions yet, but when you see what the graphs look like, then maybe you'll see what my apprehension is. So f of g of x is 1 over blank plus 2 minus 2. And then in that blank, I'm going to put 1 over x plus 2. Oh, this is such an unexpected and beautiful result. I'm so happy about this. I cannot wait. I cannot wait until we get to our rational functions unit. This is exciting. Hold on a second. Look, okay, so what do we notice first?
You go away.
Yeah. And then we're, for the third time today, going to do a little of that copy.flop action, right? So the problem inside this white rectangle here, or it's kind of a rectangle, is 1 over 1 times x plus 2 over 1. Right? Which means it's really just x plus 2. And then if you bring down this minus 2, it means this one actually flipping works, which means God, I need to set myself a reminder that when we get to our unit on graphing rational functions with vertical asymptotes and stuff, that we need to come back and look at this exact same problem, because this is so amazing that that function is its own inverse. I never would have suspected that.
Yeah, so it works.
Yes, hey,
But then,
I did.
oh,
It's there. I recorded, but I'm so excited. So maybe we can look back at this one day when we get there. I don't know when we do rational functions. It might be next. I don't even know. It's exciting.
And given the numerators just changed on 8, like 8 has to work. Because it's the exact same function.
Let's find out. It 8 worked also? Rad. It's got me wondering about these, if any function of that nature is its own inverse. I'm going to use Desmos real quick. I'm just going to stay recording while I use Desmos because I think that this is rad. So yeah, it's exciting. So the graph of number 7 is 1 over x plus 2 minus 2. There it is. That's why it's an inverse with itself. I'll be darned. That I know, it's okay, but I was going to tell you this yesterday, and you can ignore me if you want, but that blue line is the essence of all of this. The blue line is called y equals x. And if two graphs are symmetric about that line, then they're inverses of each other. And you can see that if you were to graph that function, which Desmos just did, do you see how it's a perfect mirror reflection across the line y equals x? That's why it's its own inverse. That's remarkable.
So if it's,
That's amazing.
if they're the exact same function,
Not always.
not always.
No, it's just working for this because those are rational functions, and rational functions take on, like, there's going to come a point maybe in a couple weeks or a couple months where we do a whole unit on graphing these, like vertical asymptotes and the curves and all that. And that's why it's its own inverse. How is it that I've been on this planet and doing this for this long? And I didn't never think about that.
I'm pretty sure it works on anything.
On what?
Pretty sure it works on heat.
I believe, yeah, Layla said she worked through 8 and it worked on that too. Like, look, I can show you, like, if I change it to say 3 over x plus 2 minus 2, yeah, it's the same idea. You can see how it's symmetric about the blue line again. So those are definitely remarkable.
9. 9's kind of weird.
But look, if I change this to like a -7, do you see how now it's off kilter? See how they're not symmetric about the blue line? So the observation here is that, so like if I change this one to like a +7, then you see we're back to symmetry again. That's what makes the cancellation happen. Sorry, Coop, what were you saying?
9, it's like, I just ended up with like 1 to begin with. The for f of g of x, it's no, yeah.
I don't know. That was a lot. That was a wall of words you just threw at me. Let me,
F of g of x ended up as a 1.
Oh, just one.
They can't even.
you got one?
I,
Well, let's go through it and we'll figure out.
Yeah,
So for number 9, f of g of x would be blank minus 2 over 2. And then in that blank, we're going to put the other function, which is -3 minus 3 halves of x.
and you have to copy that 12 there.
Yeah, I'd probably combine a little stuff on top first. I'd probably combine these two yellow numbers just because I feel like I'd rather have less stuff to deal with. So I'm going to put those together and I'm going to rewrite this as -3/2 of x minus 5 over 2.
And then
Like it has to equal 1, right?
No, and there's no 1. Like the x isn't going anywhere. So I don't see how it could equal
I have a
1.
question.
Did I?
Do
Yeah.
you not put the X into your denominator when you copy that part?
I'm sorry, I must not understand your question. Like all I'm saying is like this x can't go anywhere. Like it has no one to cancel with. So for you to say that the answer is just like Layla's answer, at least I'm buying because she said x. Like that x has no way to cancel out or go away. Right? We're just simplifying. So your answer can't be a number. -2x, x, 1.5x, 5x, -7/2 of x. It's got to be something that has x in it. That's the bottom line. Hold on. Yeah.
Could you split the fraction in half to -3/2 over 2x over 2 and
You
then
can.
-5
Mhm.
half?
Yeah, I mean, at the end of the day, what it really boils down to is, and you know this from, let me give you a simpler example. Like throughout the years, you should know, sorry if you don't, that would obviously be my fault. But if you had like 4x minus 12 divided by 2, I hope you know that the answer is 2x minus 6. Like, I hope you buy into the fact that you can do that double diagonal division, right? So that's the way that could work there. Well, we could employ the same thinking here. You could go this way and do this problem, and that would be -3/4 of x. You okay with that? Remember,
Yeah.
just dividing by 2, so I make the bottom twice as big. And then if I go, this is what you're talking about. And then if I go this way, then I get -5/2. Listen, at the end of the day, quite frankly, we could have stopped here because if I simplify this all the way, like if someone put a gun to my head and said, simplify it all the way, I would make a strong case that I could get this far and say, I'm done. I might have even been able to make a strong case at this point, the bigger white box, and say, I was done there. Like we look at this and say to ourselves, like, what else could we do? Is there anything to cancel out? No. Are there any numbers that we could just like add together? No. It's just done, right? So I think you could have stopped at either white rectangle and said, this one's not going to work. But Coop, again, it's got to still have an X in it, right?
Yeah.
Okay, good. Annie, you got a question?
Yeah.
Sure. Ooh, this looks fun. Number 11. Did you do f of g first, Anna? Okay, so f of g of x. I'll stick with my same color scheme. So f of g of x would be -1/2 of blank minus 1. And then into the blank, I'm going to put the other fraction, which is -6 plus x over 2. I don't see good things coming for the record, but this isn't one where I'm comfortable throwing in the towel. I might be surprised by this. So fundamentally, we just have to think about simplifying this yellow box. And what that's really going to be is just a simple matter of top times top and bottom times bottom. There's nothing that can cancel out. I will say, yeah, we got to be really careful. So the top, the answer to this white rectangle could be a little bit of a danger zone for us. If you think about doing -1 times that top, it becomes 6 minus x. Do you see that? And then the bottom becomes a 4. And then there's a -1, which I'm going to make my 1 look like this. So I'll use a color for you here. This green circle became this green circle because I knew I wanted the denominators to be the same. That's all part of that simplifying process. So then we wind up with something over, of course, 4. What's that top going to say?
1 minus x over 2.
Uh,
Or in this case, 2 minus x.
yeah, that's better. And I feel again, like we have enough evidence in front of us now to verify that that's pretty well done at this point. Done enough that there's no way in God's green earth that this is ever going to come out and say, poof, look at me, now I equal X, right? I mean, we can only work with what we have. These aren't equations, so we can't like multiply them and add stuff to, we work with what we have. So that's a big no for me. You're welcome. These are fun. It's nice, huh?
But it's not a inverse function. I hate it.
When you're just left with a little bit of a mess. It feels unsatisfying, like business unresolved. Emma, how you doing? I'm still recording while I'm pouring my coffee. I should probably pause this recording. Do you guys have questions while I'm still going? Did I hit resume? I did. Yay. I get a fresh page up here. Okay, so number 12. We're going to do f of, are you okay with f of g first, Coop?
Yeah, that's fine.
Okay, so f of g is going to be the opposite of 3 over blank plus 2. And then in that blank, I'm going to put the other function. I broke my color scheme here. That's okay. I'm going to put g of x in there, which is -3 over x minus 2. You see it?
I just have a problem copying.
I think you're probably good, but let's finish it off. These twos are going to cancel each other out. And then we're left with a simple copy dot plot problem, which would be -3 over 1 times -x over 3. Still good?
I'm so confused about the 3/1 because it's
We were wondering, why do I keep doing that?
3/1, so is it like, oh, you're just rewriting it as,
That's not a fraction, but I want it to be a fraction so that it can fraction with its homie fraction, right? That's why we put things over
you just
ones.
drop the division.
Yeah. Oh, better?
Yep, you end up with like,
And then you can see that the negatives cancel and the threes cancel. So that's why this side of it works. Do you want to go the other way together also?
sure.
Okay. So if we do the other direction, if we do g of f of x,
Oh,
then that's the negative of 3 over blank minus 2. And down in that blank, we're going to put the function. It's hard to keep track of all this. The function f of x. So down here is going to go a -3 over x plus 2.
Right.
So I'd like to draw your attention to something so we can keep this as simple as we possibly can. You agree that this is a -3,
Yes.
and you agree that this is a negative something. You also then agree that a negative divided by a negative is a positive,
Yes, you want.
which gives us the right then to just omit the negatives because they're going to divide out and cancel out anyways, right? And here we go again, Cooper. We're going to put the 3 over 1, then we're going to multiply it by the flippy flop at the bottom, which is x plus 2 over 3. And then you see the 3's cancel, 2's cancel after that. And you're done. Did you get them all? All right. Nice job. You're back in the saddle again.
for my 68%.
Of course we can. Yeah, you getting a 68 on a math test is like Tiger Woods taking like a quadruple bogey on a simple par 4. Does it happen? I guess it can, but should it? No.
an 18 or H? Bother me. It's
It's
just
18,
an
17.
Is that going to keep you up tonight? Well, now
Oh, I didn't know this. I wrote it down.
on the test, I'm going to make it like G of X and J of X and M of X. Yeah.
I'll just do.
So number 15, which way are you going first? Which way do you want to go? Okay. So we're going to do G of F of X, which, and again, the way I like to do it is take the main function and write it down. So it's -4 blank minus 5. And then into that blank, we're going to plug F of X, which is -X minus 5 over 4. So far, so good. Okay. So I think the hardest part sometimes, like as a mathematician, it gets easier as you get like older and you do a bunch of this, but the hardest part is sometimes to know what to do next. Like, I don't know how to deal with all the negatives. I think the simplest way I can explain this to you right now is we should immediately murder off those 4s. But I want you to know that I'm very purposely leaving all the negatives behind because I want you to see something. You still with me? Okay. You figured it out. Okay. Do you want to finish? Okay. So if we take this negative now that survived the 4 when we did the 4 slaughter, then that negative is going to distribute in now and it's going to turn all of this stuff inside into, say, X plus 5. And then on the plus 5 that we just created and the minus 5 that was there from day 1 cancel out, then we're left with X. Do you want to go the other way? Okay, so that was G of F and it was a swimming success. Now we're going to do F of G. Oh, I'm going to pause the recording real quick so I can ask you this question. Okay, so F of G of X is going to be, we're going to copy down the function named F, and he is negative awkward void minus 5 all over 4. And in that awkward void, we're going to put negative, oh, this is a nice one. This is not a pleasant little problem. Negative 4x minus 5. And now we just have to math, right? And the math here, I hope it's obvious that we have to distribute first. So this is going to become 4x plus 5. So we have 4x plus 5, and then we have that residual minus 5 from there, all divided by 4. Then you see it, don't you? Okay, good. So the 5s go goodbye, and then the 4s after that go, and we're done. Whoa, talk about timing, huh? Oh,
Seriously?